Hello. Thanks for joining in. My name is Naren. I manage the video tech at Vimeo. I'm here to present the awesome work from the video team. Since the beginning, Vimeo has always focused on creators, allowing them to host high quality content, share and sell. It's really fulfilling to be serving a really vocal and vibrant creator community. And here are some of the numbers. The interesting number is that we have about 240 million monthly viewers worldwide. A bit about video tech at Vimeo. Not very long ago, we had HTML5 player. We had only two options, either play HD or SD, and you had to toggle between them. Then came along Dash, and Dash allowed adaptive video streaming. That means you could get the best playback given your device capabilities, network conditions, and it was awesome. However, there were not many browsers that supported it. Then right now, all the modern browsers support Dash. They have a media source extension standard. Now you can play adaptive streaming without any plugins. So at the time, we had two options how to do adaptive streaming. We were doing HLS on Apple devices. We relied on the CDN's dynamic packager to transmux progressive videos to Dash and progressive videos to HLS format. And however, there were not many CDNs at the time supported Dash as the transmux format. And we had two choices. Either one was easier and the other one was the harder one. One easier one was take the HLS and convert it into Dash segments at the client. We thought that would be add latency and probably not the best approach. The other was harder. Approach was to build an origin. So here is the summary of how the Dash playback works. You have a Vimeo player. Here is the media source player that fetches the manifest from the CDN. Assume that it's not in the CDN caches. It goes all the way to the packager, and it creates the manifest, serves back the manifest, and the player decides by then what's the highest quality to play, given the device display size, device network conditions, and so on, and picks the best Dash segment and then plays back. So anything on the right side of the CDN is obviously origin. And there were multiple ways to build the origin. One was to take these transcodes and then convert them into two different formats. One for Apple devices, that's transport stream format, and the other one is fragmented MP4s. And that would mean that you end up having 3 times the storage. That's obviously not ideal. The other option is, like I said, a lot of HLS players, there were plugins to Video.js that would take the transport stream and then convert it into fragmented MP4 on the browser, the client side. So that's something that was not ideal for us. So what we did was they took the harder option, that is building an origin. And one does not simply build an origin, not without good reasons. And here are some of our reasons. Support new codecs and formats. Since obviously this talk is about how we build the origin. We'll go into technical details pretty soon. But since we built the origin, what we did, we added HEVC support, we're adding WebM support, and we now serve from multiple CDNs. We optimize for low latency and high throughput. We heard time and again, like the last couple of streaming media has been all about QoE, and even it's paramount. It's of great importance that we want to have the fastest startup times and without any rebuffers. So that's basically optimized for low latency end-to-end right from the player, which I'll explain in a bit. And then innovate around packaging and storage. So we don't want to make multiple copies of the same thing. At the same time, we also have a better understanding of where to store our files and what should be the format. And that's the focus around building the origin. We still want to use multiple CDNs. We don't want to build our own CDN, which doesn't make sense for us. So, like every successful software project, you have to have a great name. And so here we came up with a name, which is awesome, which is a transformer. It says its chassis is cutting edge and kept up to date. And that's exactly what we've been doing. This is the high-level flow for the Vimeo player. We have multiple CDNs now. We have Akamai facility level 3, and this is the origin. We have a Skyfire packager running on Google Cloud compute instances, and we have Google Cloud Storage as the origin. It's not limited to it. The packager is written in a very flexible way that you can plug in any origin, any progressive file storage. And here is the high-level architecture. So we have two pieces. We have HA proxy for load balancing, and we have auto-scaled manifest generation using grapl, which is again is a transformer, and chop, which does segmentation. It's very simple. Like you have a manifest which has all the list of transcodes and the segments, and we need a player to pull the manifest and play back various segments. So as simple as it sounds, this is the deployment, still high level. We're doing about 140 gigabits per second peak at the edge, about 2 billion requests a day, and we're doing 36 gigabits per second peak at the origin, about 490 million requests a day. And as you can see, there's a HA proxy cluster, and we have, for reliability, we have two Google compute regions, one in US East, another one in US Central. We have a ready to go. In case of failover, we can always fail over to US West. And in fact, as Google churns, Google Cloud churns, and as many regions, we can add them. We have an auto-scaled cluster for manifest and segment generation, like I mentioned before. And so a bit of load balancing. So as soon as the request comes in, we have it goes to the origin, and you have this HA proxy cluster, and it decides which manifest generation grapl instance or the chop instance to go to. The way we initially did was we were doing least connection, and however, a lot of the content is similar. As you can see, like we could cache if we did distributed consistent hashing. So if we did, but however, with consistent hashing, we had run into a problem like thundering herd, where one server gets overloaded and it's not optimal. So what we decided was one of the engineers implemented patched HA proxy with an algorithm called distributed consistent hashing with bounded loads. What it did was it still did consistent hashing, but prevented a server from getting loaded. And here is one example like where we have actually contributed to open source and made things better. This is something that can be used for a lot of applications, as you can imagine. So also HAProxy cluster does SSL termination. So from the, let's say from the traffic is coming from Akamai. Akamai talks to the HAProxy. It's authenticated using, we have an API key, and it's over HTTPS. It identifies that it's Akamai, and then serves the manifest or the segment. And we have auto-scaled instances. So we scale up and down. Obviously, the traffic is not the same. We have peaks and we have lows. So all these instances are auto-scaled. So what that means is that as soon as this instance comes up, we have used Google startup hooks to register with. We have to have more than one HAProxy to do the load balancing. So we need an HAProxy cluster. However, there was nothing to manage this HAProxy cluster as we scaled up and down, like either removing the instance or adding the instance as we scaled up and down. So we went ahead and built, we had not yet open sourced that, but we built a HAProxy cluster manager which did exactly that. So as the instances came up, they registered with the, we call this highly available, registers with the cluster manager. It then adds, sorry. What was this? That's pretty rude. Sorry. I set an alarm. I didn't think it was. I was on vibrate, and for some reason, all right. So going back to. So we have talked about the auto-scaled instances, how we manage them, and we built a packager. I said that one of the core things was we could, if we go back to the slide, we talked about the manifest being MPD, which is dash manifest, M38 for HLS, and JSON for. So we came up with this our own custom manifest format, which is JSON. Because we built our own packager, we could do that. Also, we saw -JS, and pretty much everybody converted the XML format into, into the segments, to the JSON format, and then pull the segments. And we also have this custom segment pattern. What it does is, we talked a lot about improving the startup time, and it's very obvious, like the lower the startup time, it makes the users not abandon the video. So we built a custom segment pattern in the packager, which means that we can do, we chunk the segments, we transcode the videos with a keyframe interval of 3 seconds. That means we can have a segment that is multiple of 3. So we can have a segment pattern which is 3 and say 3 segments for, let's say, 4 3 segments, and then start with 6-second segments. So we improve the startup time, but also not, we want to have the segments long enough for the playback to be smooth. And we had to write a custom MP4 parser. We had to do a lot of custom HTTP I/O layer optimizations. So one of the things about Google Cloud Storage we found was it had awesome time to first byte and the read throughput, but there were a bunch of long tail latency. So what we did, how we addressed was like we would had an aggressive timeout and retries, and thereby make sure that we're pulling the content. If it's taking longer, we make another connection, and we do a lot of parallel requests to avoid that. So we have heavily cache at every tier, obviously, to reduce the number of requests going to GCS, even though the performance was great. One of the things we were doing was we were cache move and also segment analysis. so that it can be used for by ChopShop and also Grapple for initially making the segment, for initially making the manifest, and also segment generation. And we use the memcache cluster, and we also have a local cache, which was more useful when we switched to consistent hashing, because now it could use the cache on the instance. So this is how the Google VM instance looks like. It has Grapple for segmentation, for the manifest generation, ChopShop for segmenting, and Crosscut for subtitle management. And we use these two main video libraries. These are the FMPEG libraries, libbaby codec and libbaby format, which is pretty much standard across the industry. Pretty much everyone uses it from Netflix to YouTube. We use LSmash for MP4 parsing, and we use libbaby format for transmuxing. And we did 3 out of 4 engineers in Vimeo are FMPEG contributors. We improved the performance, and also we fixed a lot of bugs and contributed back to open source. We use 2-tier cache, like I mentioned, Vimproxy to proxy through the memcached cluster, and we have LRU for local cache. And we use a lot of monitoring and instrumentation, which I will talk in a bit. We use CollectD for system monitoring, Nero for application monitoring, which all the blue components are built by us. Error logging, we use Google Cloud Logging, which is awesome. So we can set thresholds on if there is any for anomaly detection and stuff like that. Nero we built because we couldn't use StatsD. We wanted a lot of custom stats. We were doing a lot of instrumentation. We even overrode the FMPEG network library using their custom I/O, and thereby we could do retries and do all that awesome things I was talking about. And we use LSmash, but we use a custom MP4 parser to reduce the. We wanted to be as less CPU intensive and memory intensive as possible. So we do a lot of things in Go. All the services are written in Go, and which has been great because it has a good C interface and very good for scale. This is the instrumentation from Nero, and this is from ChopShop to GCS. It's about 130 milliseconds average, and which is and the packager is adding about 40 milliseconds. This is from the origin latency, and then we use, as I said at the beginning, Fastly and Akamai, and level 3. Fastly has this real-time logging, which we used to monitor from the air shield to the origin. Our origin, the latency was about around 100 milliseconds. We constantly try to optimize all of these, and there's a bit of CDN origin integration. We work closely with all the CDN vendors. It's very important that we pay attention to the timeouts, retries, and how they can fail over in case US Central is down. And we are at the beginning of the development. We wanted to be able to purge incompatible versions should we release a bug. We usually don't do that, but should we do that? So we could, at a time, purge the entire library with any incompatible version. We come up with an innovative signing. Probably running out of time, so I will briefly explain that. It is we didn't want to use cookies for authentication. We also didn't want to use ESI. So this was packing into the path the expiry and the signature, and the signature is based on the asset path, which is usually the video and all its renditions, and the expiry is that the CDN validates this URL and it makes sure that it's authorized, and then it strips out the first expiry and signature from the path and sends it to the origin. And we talked about how we authenticate the CDNs as well. So one of the things that which was very new to us was like when we had everything on origin and we used the same CDN for origin, we didn't care about egress. We didn't know about that. So all of a sudden we had to start worrying about egress costs, and then just basically we had to choose the CDNs that most of the CDNs have preferred pricing with Google Compute and Google Cloud Platform. So it worked out fine. And then some of the vendors like Fastly have a faster interconnect between the Google Compute, which we leveraged. And also, we need to watch out for interregion prices between Google Cloud. We worked with the CDN. So suppose the US, usually the outages would be that, not really outage, performance problems would be a certain region, compute region, not able to pull from Google Cloud Storage. In that case, we would get the compute pulled from, sorry, what's this going on? Oops. I'm going to switch this off. Sorry. We pay attention to the cache hit rates. Cache hit rates are very important because that determines, if you have a higher cache hit rate, it boils down to lower egress costs and also better performance for users. So we work with all the CDN vendors to improve that, and we're constantly looking at ways, especially we have about 75% cache hit rate with considering the long tail content we have. It's pretty good, and we are constantly looking to improve. One of the things we did with Fastly was we did edge sharding so that all the content is going to making sure it's going to one shield node. And then with Akamai, we did a lot of improvements with two-tier cache hierarchy, and we work with, we also do a lot of improvements with, right now we're testing with Akamai Quick. Quick is a UDP-based protocol that helps, it's unlike, which is TCP protocol, which has a lower round trip, almost zero, which helps faster startup times and also throughput improvements. And we're testing HTTP2 with Fastly. Key takeaways we wanted to go with the MPEG-Dash first approach, which paid off because last year Apple announced that they would support fragmented MP4 and M308, and we right away enabled that, and it didn't take us more than a week to deploy. And we saw that there was, for our kind of traffic, there may be claims about a lot of reduction in the segments, transferred stream versus the fragmented MP4. We saw about 5% efficiency, so by switching, and it was flexible and cost effective. We could do very interesting things with the storage. Google Cloud Storage has various tiers of pricing for cold storage, nearline storage, and things like that. We haven't gotten to that, but we can, if we know ahead the pattern, traffic pattern, and we know it's going to be not played, we could do that. And we have scalable and performant, and talked about how we're scaling, how we are optimizing end-to-end latency, and how we have added reliability by multi-CDN. We even can do multi-origin. We've tested Google Compute with level 3 origin. And these are the playback stats. We're doing about 90% dash if you add up to HLS and with fragmented MP4. And obviously, we still have progressive, and we are working on how to address that. We have more than 50% HD plays, a small percentage of 4K plays. We're improving. We're trying to work on improving, and we are adding WebM support or HEVC, things like that, that could make us play 4K even at a lower bandwidth. So our future is transcoding to mezzanine, dash mezzanine, and doing on-the-fly HLS TS. As you can see, transfer stream is only about 2.5% traffic right now. It makes sense, and We do have a flash file fallback which does HLS, and we have real-time QE data now. We are one of the things we did was we have all these origin logs in BigQuery. We have the CDN logs in BigQuery. We understand where the miss is happening, where the cache, how the cache is flowing, and we can. A lot of interesting work is being worked on. Like we can tell with a 96% accuracy whether this is going to be played or not. We have end-to-end instrumentation right from the player. We can have the QE data. We have all the egress data, and so we want to do some interesting things like we can choose the multiple CDNs wisely, without without compromising performance, but still being cost effective. And questions?
When you do your multi-CDN strategy, right? Do you base it on performance, or do you base it on regional coverage? And if you base it on performance, how often do you switch between the CDNs? I'm assuming you're not flapping very frequently, right? So what is the kind of criteria you use to, or the time period over which you measure, to say, you know what, this particular CDN A performance isn't good, I need to move to CDN B. I mean, what's the criteria you use?
So right now the question is what criteria we use to switch between the CDNs, performance and cost, and regional efficiency. So right now this multi-CDN optimization is very straightforward. We want to improve the cache hit rate initially, and we pick the CDN only based on the regional efficiency, and we want to do all this real-time logging is to improve that. If there is a CDN that's not performing, we do mid-switch to the CDN we think is better. But right now, it's at the beginning we pick a CDN which we think is the best. We want to get better at that using all the various data we have, data points. Any questions? All right, thank you.